Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutewa Sos Ugobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so we have question 7. It says in the diagram below, the graph of f of x is equal to -2 sine x is drawn for the interval x element of -180 degrees all the way to 180 degrees. And then 7.1 here says on the grid provided in the answer book. So we're just going to use this one here. Draw the graph of g of x is equals to cos x minus 60 degrees for x element of -180 all the way to 180 degrees. Clearly show all intercept with the axis and turning points of the graph. Right. So we are required to draw the graph for this one. Now, for that one, you can just use your calculator. So all you're just going to do is press into table, and then you make your g of x, the cos x minus 60 degrees, and then you start, where it says start, you're going to start from -180. Where it says end, you're going to end at 180 degrees. And then it's going to ask you for step. So in your step, this is what you are going to do. So in order to find the step, basically you just look at your interval here, because you want to draw it as precise as possible. So we have 0 to 90, but then we can see that we are given 3 blocks in between. So we can find the step by simply taking the -90 degrees and divide it by 3. So we want to find the values in here. So if we divide that by 3, we have -30. So that means here we must have -30, and then the progression of your x values will be by 30 degrees. So -30, -60, this will be -120, and then here -150. So of course, when we are on the positive x-axis, this will now be +30. So from 0 to 30, and then 30 added by 30 again, that's 60, 90 add 30, that's 120, and then here we're going to have 150. So now you are set for your interval or your step. Then at this point, that means we can now draw the graph here. Right, so starting from -180, if we punch in -180, it gives us a value of -0.5, which can be here, because that's the midpoint of 0 and -1. And then when we punch in -150, that's -0.886, which we can predict it to be somewhere there. And then as we move along, we have -120, which is exactly at -1. And then -90, we have it at again a -0.866. So that's it there. And then it goes all the way like that. So if you can just continue with the values like that, they will kind of make that shape there. And then now you have something like this. Now you have something like that. So crossing over here, and then crossing over there. So it will cross over this point here, and then be at this point. So now when we punch in the 30, it's there. When we punch in the 60, that's where we get 1. So at 60, it will be at 1. And then it will just cross over like that. So still using those values, then it will have to pass over the x-axis at 150 degrees. And then now it crosses over there like that. Okay, so now you end up having your graph of G with a shape like that. So if you are using your points, if you are using the graph there, and then just simply plotting those points and then joining all this to form just that smooth curve like that. And then you have to then label this one as the graph of G. And then just like that, you have indicated that. So can just indicate these ones to show that those are your point of intersection. And then now they said clearly indicate the intercept with the axis. So those are your intercept with the axis. And then this here are your turning points. So you can just boldly shade those ones so that they are clearly visible. So because they said clearly show all intercept with the axis and turning points of the graph. So we have our turning points there. The turning point here is occurring at negative 120 to negative 1. And then here it is occurring at 60 degrees is to 1. And then we have our intercept at negative 30 and positive 150. Right. Okay, then 7.2 says, write down the period of f(3x). Now, we've already spoken about this when it comes to functions. We said this here indicates that in this position here, in the position of B. So remember, this is in the form of y is equals to AB, in the form of y is equals to A sine bx. So this 3x here is simply affecting this part here. So the 3x is affecting this part. What does it mean? It means that what will be the function of x if now that is 3x, right? So if you are now replacing the x by 3x, so that means now the new function is negative 2 sine 3x. Now we want to know what is the period, but then you will remember that we mentioned that the period is affected by this number here. It is affected by this b here, right? So if we want to know about the period, we simply look at this number here. And then since we know that the mother graph for sine has a period of 360 degrees, that means in order to find the period for this graph here, we will need to say 360 degrees divided by 3, right? Now, if you say 360 divided by 3, we end up with 120 degrees, meaning that our period is now 120 degrees, right? So that's how you find the period. So always know that when we are dealing with sine or cos, it's always 360 divided by the number that will be here, right? But it is not the same thing for tan. For tan, you say 180 divided by the number that's in here, because tan has a period. The mother graph for tan is a period of 180 degrees. Right. Now, 7.3 says use the graph to determine the value of x in the interval x element of negative 180 degrees all the way to 180, for which f of x minus g of x is equals to 1. So what is the meaning of this? This is where when you take the y value of f of x and you subtract a y value for g of x, you will get your solution as 1. Right. So all you have to do in order to answer this is just to look at this vertically like this, right? So if we were to just look at this vertically, let's say, suppose we are considering from this part 180, we can see that from the value that we have here, this is 0 and this is 0.5, will never produce 1, right? So remember, we must produce the 1 from taking the value of f and then subtracting the value of g. In other words, the graph of f has to be the one that is above and the graph of g has to be the one that is below. So looking at this again, we can see that we cannot produce a positive 1. Looking at this distance over here, we cannot produce a positive 1. Also with this one, we will produce a value that is greater than positive 1. Looking at 60, also this one would be greater than positive 1. But then we have something peculiar here. Let's look at this point here at negative 30 degrees. What is the value of f of x? That's 1. But what is the value of g of x? That's 0. Now, if we can take that point there, we can say, okay, if we mainly say f of x minus g of x, at that point, let me indicate at f negative 30 degrees and then g negative 30 degrees, we can see that our value for f negative 30 degrees, that's a positive 1, and then g negative 30 degrees, that's 0. If we say 1 minus 0, that's going to give us positive 1, which is basically what we are looking for here, right? We are looking for the points whereby when we take the y value of x and then we subtract it to the y value of g, we're going to get a positive 1. So that occurs within that point. Now let's locate others. Can we find the same thing occurring? Here, obviously no. Obviously no. obviously no, obviously no. But with this one here, it would be the case, but then note here, the graph of G is the one that is above and the graph of F is the one that is below. So this one would produce -1 instead. But then here they're looking for +1. So we can clearly see that that is only occurring at one point when X is equals to -30 degrees. So our solution for 7.3 should be when X is equals to -30 degrees, because that's when we can take the Y value of F and subtract the Y value of G and we get +1. Okay, now 7.4 is saying write down the range of K if K of X is equal to half G of X plus 1, right? So G of X, the G of X that they're speaking about is this graph that we already have in here. Okay, so now if we were to determine the range, note from the previous question how we answered this. So number one, you want to actually determine the range of the original graph. Remember here there's been transformation already, but then now we want to understand originally where it's coming from. So originally it's coming from G of X is equals to cos X minus 60 degrees. Now the range for G of X, the range of G of X from this one originally is just our minimum value would say Y is an element of -1 all the way to our maximum value is +1. So originally this is the range that would have for G of X, right? But then suppose now we have half G of X, right? Suppose 7.4, we only have half G of X. What will be our range now? We do understand that this simply means that now we're going to end up with half cos X minus 60 degrees. Where do I get this? Remember, this is G of X. This is the equation of G of X. So if I'm having half G of X, that means that's half cos X minus 60 degrees. But we've spoken about the effect of the A here. We said this directly affects your amplitude, and then by affecting the amplitude, it also affects your range, right? So now that we have half, we already know that our range for this one would have to be Y element of -half all the way to +half, right? But then the +1 here is indicating that this graph is not only just being reduced by a scale factor of half, but then it is also being shifted 1 unit upward, right? So it is not only being reduced by a scale factor of half, but then we also see a shift upward, right? 1 unit upward. So this means this will also affect our range. So our new range now for K of X, so range for K of X, now that we have shifted it 1 unit, would have to be Y is an element. We'd have to come here and try to shift this range here 1 unit. So if we say -1/2 plus 1, so we're going to say -1/2 plus 1, and then that's going to give us +1/2. But then also we must shift our maximum 1 unit upward. So this is going to end up giving us 1/2 plus 1. This is going to be 3/2, right? So our new range now for K of X, which is equals to half G of X plus 1, will be 1/2 all the way to 3/2. So note the transformation that took place. Number one, it was reducing the graph of G by scale factor of half. Then from there on, we shifted the graph 1 unit upward, and therefore our range, we ended up having half, Y is an element of half all the way to 3/2 included, right? And that's how you were supposed to tackle this question here. Please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And then if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. And if you're watching from Facebook, please follow and like the page. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.